Buenos dias, muchachas y muchachos. It's Mr. Finn again with another edition of Honors Physcics. For today, we're going to talk about that demonstration we saw at the end of the video yesterday regarding the balloon interacting with the electroscope, but the electroscope moving opposite the way we thought it would move. So remember the two ways we've already seen. We've already seen conduction, we've already seen friction as ways to charge an object. But there's a third way of charging, and it's called induction. What is induction? It is charging an object without direct contact of the charged object to the object you're charging. Let's look at another again. Okay guys, here's what we did yesterday. We took our balloon and we put a little charge on the balloon by friction. We brought that charge close to the scope, but at the same time my finger was on the opposite side of the scope. When I remove my finger before I remove the charged object, then what I've actually had happen here is I've polarized the scope and my finger. So my finger and my electroscope are considered one item. Now, what do the electrons do in the face of this negative charge? As this negative charge comes close to the scope, electrons in the electroscope, instead of running down into the bar, they run away into me. I am the ground, the infinite reservoir of neutral charge. So if electrons are running into me, away from the scope to get away from the balloon, because opposite charges attract and like charges repel, so these are like charges running into me, that leaves the scope with a deficit of electrons, meaning that the scope becomes positive. Since I removed my finger first and kept the charged balloon nearby, I separated while we were polarized. That creates a positive charge on the electroscope. So if I bring my charged balloon in here now, okay, I'm back to neutral because I grounded the device. I'm bringing my charged object in, remove my finger, and now a charge is stored on the device. As I bring my negative charge in here close, you can see the bar goes back to a more neutral position. Guys, this is charged by induction. So this is a positively charged scope if the balloon is negative. And over the course of time and demonstrations, we have proven the balloon to be negative in this case. All right, let's go to the board for more details. Before we do, let's ground this scope. Okay guys, let's take a look at the recap real fast. Induction is our third way of charging an item. Induction is a process of charging an item without direct contact of that item to the charged object itself. But we have to polarize the object first. Process of charging by non-direct contact, without direct contact, polarization must precede charge by induction. So my finger and the scope had to polarize, meaning electrons had to flow into me. Now, is it dangerous for electrons to flow into me? Not really. The charge is so small that it really wouldn't make much difference. I am an infinite reservoir considering the amount of charge we have on an electroscope. Now, could it be dangerous? Of course it could be. If I absorbed a lot of charge, that would be a lot more energy. We're going to get to that in a little bit. But for now, polarization must precede induction. But grounding may or may not occur. Now, I used a process of grounding because I became the ground. But if I had two scopes with a bridge between the ball and the charged object coming to one, then the electrons from the first scope would move to the second scope. Then, in the presence of this charged object, if I simply separated the scopes, one would be negative, the further one, and the one closest to the balloon would be positive, but no grounding would have taken place. This is an indication where grounding does not occur. Now, if you guys are looking for more on this, please view the video on Crash Course Physics, by Crash Course Physics, on electric charge and fields. It's a great way of looking at charge by induction. And she goes really fast, but she's got really cool demonstrations in there. I would check that out. If you have questions, let me know. Okay guys, that about does it for today. I know we had kind of a shorter lesson today, but you do have that Google form today at 3 o'clock. Now remember, we're just talking about a few basic items in terms of the static section. We have the 3 ways of charging: friction, conduction, induction. We have Coulomb's law, which is F equals KQ1, Q2 over D squared. We have grounding, and we'll get a few more things going on this at the beginning of next week. As another announcement, next week, the district is coming out with a collaborative plan for online learning for all Farmington Public Schools on the 16th of next week. They actually designated the 13th and 15th for PLT time between teachers. So if we don't have a video one of those days from Monday to Wednesday, it's because I'm doing some PLT with my other teachers on physics. But for now, you guys have enough information to work with and getting into Coulomb's law and some of the information from chapter 16. So, hope you guys are okay today. Good luck on the Google form. Make sure you complete that between 3 and 6 today. All right? And then have a great holiday weekend. We're off on tomorrow because it's going to be Easter weekend. And we'll get back together next week. Now, I may have a video ready for Monday just to get you guys up to speed. But there's some PLT time. So, have a great weekend, guys. And we'll see you then.